Hello, this is Kevin Byrne. This is my final year project presentation for the BSHCE in computing in the software development stream, and the project is titled Tetris Flow. Okay, so I'll start here with some slides explaining the concept, goals and implementation of the project. I'll then proceed with a demo of the finished product, and then finally we'll do a quick walkthrough of the code. So first of all, the project is called Tetris Flow, so there's the name at least derives from the video game Tetris, and flow is the term for a focused state of mind, which is described in positive psychology. So what is Tetris? So Tetris is an extremely popular video game, but in case you're not familiar, we'll just briefly have a quick overview of the game. So it's a tile matching puzzle game, where blocks known in the game as tetraminos fall from the top of the screen. Tetra coming from the four orientation of four blocks, different orientations of four blocks, which will fall from the top of the screen, where the goal is to fill the screen with blocks without any gaps in between. So you want to create a full unbroken line. When that happens, the line disappears. All of the blocks above that line will be moved down one space. Your score will increase. So the game ends when the blocks reach the top of the screen, and most important for current discussion, the difficulty is determined by the speed at which the blocks fall, so it gives you less time to react to decide where to place the pieces. Now for the second part of the Tetris Flow namesake, flow. So flow is a concept of a state of mind, a mental state of being in the zone. Is kind of one way to refer to it, and it's described by a loss of sense of time and space, which means if you've ever looked at your watch and noticed that time has gone faster, you realise you thought you'd spent 10 minutes of a task, really it's been 30 minutes, you've probably been in a flow state. And being in one of these flow states, well, it's proven to actually have positive mental health benefits. It reduces anxiety, reduces stress, makes people just generally feel good, makes people feel like what they're doing is worthwhile, whether it is or isn't is relevant. It makes them feel that way, which is good. So when we look at flow as the way it's described in psychology, we can see that the studies have shown that it's achieved when there's a balance between the skill of the individual and the difficulty of the task. And what we mean by that is that the task is not easy to do. It's something that's very complicated and difficult for the individual to complete, but they are able to complete it. So it's right on the edge of what is achievable to the individual. And most importantly, it's difficult but achievable. So it can't be something that's easy, it can't be something that's too hard that they can't achieve it. So based on that description of flow, we could see that it is difficult to maintain, it's difficult to achieve, and it's also difficult to maintain. This image here was proposed by the psychologist responsible for our current understanding of flow, who is a psychologist whose name I'm going to butcher, but I'll try, named Mihail Csikszentmihalyi. Apologies if I got that wrong, but he proposed this diagram, which shows that flow is in this happy little section of the diagram here, where we're balancing the challenge of the task and the abilities of the individual. And if we even stray a little bit outside of having a high challenge and high ability, if the task gets too difficult and our abilities aren't high enough, we go into anxiety and stress. If the challenge becomes too low and the ability is too high, we come down into control, relaxation, but it's really goes onto the way of boredom quite quickly. And when both we have the challenge too low and the ability is too low, we're down here in depressed apathy land, which is very bad to be in. So these responses are emotional responses to this state of mind. So we can see that it's lost, as you see, where you're frustrated, stressed, or too happy, even too confident. So if we can identify these emotions, we can also, by way of not identifying them, establish flow, if that makes sense. If we don't have emotion, we do have flow. It's an inverse relationship. So if we can identify the emotions, we can then adjust the difficulty of the task. If we're not in flow, we can make it so that the task, if we can make the task more or less difficult, we can hope to achieve flow or maintain flow. and that is the goal then to maintain flow. So we'll describe in the next slides how the project aims to achieve this. So what's the technology that I used in order to achieve those goals stated in the previous slide of achieving and maintaining flow? Well, the solution that I felt was most appropriate or most achievable to me was through the use of computer vision. So computer vision, my favourite definition of computer vision is software that gains an understanding from images and video. Just very succinct little way of describing computer vision, and the key term there is understanding. So if we're talking about understanding, we're talking about deep learning when we're looking at software understanding. Specifically in this case, it's going to be convolutional neural network, which is most adept at image and video recognition. So in order to implement this neural network, I used OpenCV, which is an open source library for real-time computer vision. I implemented in Python. OpenCV can be implemented in other languages, but Python is the most appropriate. I wasn't a Python expert by any means, but when I was doing this project, but it was picked it up, and I actually really enjoyed working with it, so it was a great choice. Python then used Keras. Keras is an API for the deep learning TensorFlow, which is the next point here as well. So TensorFlow, which is essentially a machine learning library, which has lots of functions and useful things there in order to build this neural network, which we'll be looking at. NumPy as well is another library that was used. NumPy is a library for working with multidimensional arrays and matrices, which is the primary data which is going to be in this neural network, so it's obviously necessary and useful. And lastly, the way that we're going to be, or the task that we're going to be modifying and having the user partake in, is a video game, in this case Tetris, if you didn't already make that connection. So we built a version of Tetris, which is essentially the regular version of Tetris that most people would be familiar with, and we developed that with Pygame, which is again a game development library in Python. Okay, so before we get into the demo and the specific code run through that I have planned, just to give you a quick overview of the architecture and data in the project. So as mentioned before, we're using OpenCV and the other libraries to create a convolutional neural network using Keras for emotion classification. The model that we're making here with the CNN is a sequential model, which is essentially stacks of layers where each layer has exactly one input tensor, a tensor being a multi-dimensional array, which was mentioned earlier when we were talking about NumPy, so NumPy is helping us with that. So one input tensor and one output tensor, so it's a one-to-one relationship. Then each layer feeds in a one-to-one ratio to the following layer in the model. And so the next, so why sequential model? Well, sequential models, they're really the simplest type of neural network that could be made, or they could be thought of that way. But really, it's perfect for our application or the application planned here. There's no real, it's not really necessary to go any more complicated than that. So it's perfectly fine in my opinion to be applied here. Next to talk about activation functions, which we'll see in the code later, but the activation function used predominantly in the network is a rectified linear unit, or ReLU as it's known. So ReLU is the most popular activation function. So that was the main driving force behind my reasoning of picking ReLU as the activation function in the network. And not because of any of the other benefits, but really mostly because as the most popular one, it's also got the most documentation, most guides, most tutorials. When I looked into why it is the most popular one, the reasoning seemed to be that it's cheaper in computation when compared to the hyperbolic tangent, or tanh, and also sigmoid, which used to be the most popular activation function. But when I was looking into it, it seemed that in our data set, which is relatively small compared to some of these larger ones, the benefits of using ReLU in terms of computation probably wouldn't have been that noticeable. So really the main driving factor is just availability of resources and information on ReLU. So that's why it's the main one. Although if there is benefits in terms of computation, we are seeing those in here. And lastly, just to there's also the softmax. So the softmax is used once as an activation function. Softmax, it basically takes the input in the layer and then normalizes it into a probability distribution, which basically we just use to make percentage predictions in the emotion categorization or identification. So whatever, it's just outputs in a way that we can understand as a probable percentage. So lastly, just to very briefly mention the data set that we used to train the model. So this is the FER 2013 data set, which is available on Kaggle for free. It's a little bit older now, but it's still perfectly applicable for a project like this. It consists of 48 by 48 pixel faces that are labeled with 7 categories of emotions. The categories being anger, disgust, fear, happiness, sadness, surprise, and neutrality, which is key, neutral being the key one in this project. And there's about 28,700 labeled images, and then a couple of other images for testing against. Okay, so we'll crack on with the demo now, and then finally we'll go into some code after that. Okay, so immediately you should see, we do see Tetris Flow. This is the video game module aspect of the application, or that's where it will show now in a moment. And on the right we have another window which is to show the Tetris Flow capture. So as you might have noticed there, a moment ago there was a little green box showed up. That's the facial identification aspect of the emotion recognition software. And then we also have the emotion recognition output, which is just showing us the percentage probabilistic percentage of what the emotion is. So it's seen there that it looks like I'm going between neutral, happy and sad. I don't know what I am. I think I'm probably neutral right now, but we'll see how well the game goes before we commit to anything. So the way that this works before we get into the game is that this is going to take the highest percentage emotion identified. It's going to feed it into the game, and then the game is going to make some decisions based on that around the difficulty, making it more or less difficult, or keeping it the same, namely. So I'm actually going to move my face back a little bit so that it's out of the emotion recognition range, because I just want to discuss the game before we get into the emotion recognition aspect. So just going to move it back. Okay, so press any key to play. Okay, so we have Tetris. If you're familiar with the video game Tetris, this should look quite familiar to you. I'm not, as surprising as it is, I'm actually not very good at Tetris, so hopefully I can actually clear some of the rows so that we can show you the actual functionality is working. I'm just going to move this down. I'm controlling this using the arrow keys on the keyboard. Left, right to move it left and right. Up is to rotate it, and then down is to speed it up. And as you see there, as I cleared one of the lines down the bottom of the screen, the score incremented and it removed one of those lines as well. Okay, so some things that kind of separate this or distinguish it from a traditional Tetris game. Well, you might notice that, well, it's green coloured. That's not super unusual, but that will be apparent why that's important in a moment. And also we can see there's a label there that says current emotion is neutral. So my face has been detected. Neutral is the default emotion for obvious reasons. If it's neutral, the game speed will stay the same. Everything will stay as it is currently at that particular difficulty level. If I move my face in, we can see a little bit of flickering there, giving it away. But depending on whether it's a positive or a negative emotion, the application is going to either decrease or increase the difficulty of the game. So I'm speaking now, so it's a little bit jittery. But if I, for example, think, okay, this is a little bit easy, I'm doing very well, and if I were to look a little bit too pleased with myself, so we can see the application is noticing that I'm happy, and the speed is, well, the speed number on the left is decreasing, but that number refers to the amount of time between each movement of the block vertically downward. So the lower the number, the faster it goes, and when it's green, it means that I'm happy enough for now. So what if the game, okay, it's very fast right now, I look like I'm a little bit worried, a little bit sad, a little bit angry maybe even, although we shouldn't be getting angry at games, but if I were, it's hard to do it while talking, but we can see that the speed on the speed variable on the left is being increased, which means that the amount of time between a block movement is increasing, so it's going slower. And we can also obviously see the label on the right is changing, and the colour is changing as well, which is just a sort of immediate visual indicator for the user what emotion they're feeling. So that's the basic understanding of the game, or the basic functionality of the game. Okay, before we look at the code, I just wanted to quickly jump back to the slides in order to go through testing and evaluation. I thought it would be better for you to see the working demo before talking about how the product was tested and evaluated. So as far as testing, there was unit testing and integration testing as part of the development process. The unit testing functions we can still see in the code, which we'll see now in a moment when we go through the code. Integration testing, there is two modules essentially in the application, the facial recognition / emotion recognition, and the video game aspect, and so how they're integrated. There was some light integration testing done there, basically passing through mock data to see that it's been picked up correctly. So that was quite easy and quite readily done, but important to make sure that the two modules are working accurately. But really the way that this application was tested and planned to be tested was through evaluation, through user evaluation. Unfortunately, with the current COVID-19 situation, the application was very difficult to get test subjects. The Tetris Flow is not portable in its current state, so it isn't hosted online, and it can't be sent to someone without a lot of setup required on the user's end in order to get it running. So actually finding test subjects was a real stumbling block and a difficult aspect of the evaluation. We did get 4 users to fill out a more detailed survey than I would have done otherwise, but really there is some problems with that, but we'll go through the results of the survey anyway. So the full results are in the report, but some highlights. Everyone agreed that we surveyed that Tetris Flow is less difficult, and therefore all users also achieved a higher score, which makes sense. That's possibly because the game was modifying the difficulty based on their ability. That's the hope. It's also possible that they were gaming the system by just making goofy faces. That's also true as well. Doesn't matter. It depends on how much they enjoyed it. At the end of the day, it is largely for recreation and making people feel good. So I don't know if it really matters, but that is the consensus. And again, most users found a greater sense of accomplishment. 3 out of the 4 guys found that compared to regular Tetris, they felt more accomplished playing this one, and generally just enjoyed it more. But speaking about the goal of the application, inducing a flow state, the results were really inconclusive. Based on the small sample size that we had, we can't say that it's any more effective at inducing a flow state than regular Tetris. I don't know if that's a failing on the application. I would say that's more a failing on the evaluation process. Ideally, we would love to come back and have a much broader testing evaluation phase, and get some really valuable feedback and bring that forward into future iterations of the product. But that's what we have now, and that's what we have to work with. So yeah, that's the testing and evaluation aspect. So I'm just going to move on to some run through of the code now. Okay, so here we see the emotion classifier. This is the file used to train the model, to build the CNN essentially. I have it open in Jupyter Notebook here. I've kept both Jupyter Notebook files, Python files, and regular Python files in the submission, so either one should work, whichever one is easier for you. So the code itself is not that long in terms of lines of code, especially in this aspect. So I'm just going to read through. I won't pick out specific. I'll just go through the whole code in a holistic approach. I'll try not to get bogged down too much into specific lines of code. I'll just give a quick overview. But immediately we can see that there's 5 epochs. Batch size is 256 and the number of classes are 7. We can open the FAIR 2013 CSV. That's the data set that we have from Kaggle in CSV format. And the first real half of this file is just preparing the data set to be used and to be used in the model and be built. So we can have a look at the dataset.head. We can see what we're looking at here. We have the usage column is training, we have the pixel values, and we have the labeled emotion, and each one represents or is associated with one of the emotions that I mentioned previously. So as I said, we're just preparing the data here. We're removing the comments from the CSV, removing the white space, converting them to the right value. Flow 32 is what we need to use here. We're separating by training and public test, getting the actual training values, separating them from the test values, and then we're just labeling the code coming through here. We're showing how many samples we have. As mentioned before, there's 28,709 samples, and then some 3,500 for actually testing once the model is trained. And that's that. We have our data set prepared, cleaned and ready to go. And here we are doing the actual interesting part of the project, most interesting part for me anyway. I've tried to keep as many comments in here as possible because I know that this is quite a dense subject matter, but we have here that we're doing a sequential model, which I've mentioned before is the simplest one. We're doing a convolutional layer to start off, and it's a 2D layer obviously because we're only looking at images. To mention that the model is trained on images. Something that I haven't mentioned before now. Even though we're using live video, we get around that fact because training video would require us to have a huge in terms of gigabytes worth of data of files in order to train a video model, and it's more complicated. There's a lot more to consider. But the way that we get around that for this is that we train the model on static images, and then we treat each frame of the video in the motion capture, the camera. Each frame of that captured video is treated as a separate image. It's probably not as effective as using an actual model trained on video, but again, based on the limitations, the time frame and the complexity, this is the way that I chose to tackle this issue. So it's a 2D convolutional layer. We can have the filter size. The activation type is ReLU. As we mentioned before, we have and because it's the first convolutional layer, we have the shape is being defined here, which is 48 by 48, and one being the color in the layers, but the fact that it's grayscale, there is only one. There's only one layer here. So after the first convolutional layer, we can see that we add a max pooling layer. So a max pooling layer is essentially useful for two reasons. The max pooling is used for downsampling, so it reduces the input. So it means that it lowers the overall computation time by reduces the number of inputs that are required in subsequent layers. But also because it sort of abstracts the input from the original input image, it's also useful for reducing overfitting. Overfitting being where a trained model is really good at recognizing the training material, but it's not very good in real world applications or when testing. So that this is max pooling and average pooling, which we'll see in a moment, are used for those two reasons, to lower the amount of training time and also in reducing the overfitting. So following the max pooling, we have two more convolutional layers and the average pooling layer, which I just mentioned there. The difference between max pooling and average pooling is that max pooling takes whatever's in the filter and returns basically the max values, while average does the same, but for the average values. And it's useful because it's not super important whether where exactly in the filter something has been activated. It's really only important that somewhere in the filter something has been activated. So the exact position is not really as important. That's why max pooling and the average pooling are useful. So model to add, we're just adding two more convolutional layers here, another average pooling layer. Then we're flattening it, which is so that it can be put into the dense layer. The dense layer doesn't work on a matrix, multidimensional matrix. It has to be flattened. And then we're adding a dropout layer again, just to help with overfitting it, just to add some variance into the data, so that the model is a little bit more robust. And then we have another dropout layer again to help with overfitting. And finally, we have the softmax activation function, which is used to output in a probabilistic format. So the reasoning behind all of this, while I've messed around with this quite a lot, and I was really just trying to avoid overfitting. That's why there's so many pooling layers and two dropout layers as well. I was seeing quite low percentages on the accuracy, and so I wanted to ensure that we were avoiding overfitting as much as possible. And I know that in the midpoint I also got some feedback that I might be encountering some overfitting based on the model at that stage as well. So I tried to do as much as possible to try and avoid that. The highest percentage, even with that I was able to get, as what's seen on the second, is only 58%. 52% there actually. I think I got up to 58% on an earlier model. So really the accuracy is not as good. There could be some more work. I think if I spent more time messing around with the number of layers, adding more convolutional layers, or changing the epochs, I could possibly get the accuracy higher, a fair bit higher, but based on the time and the benefits of doing that, I didn't really see it as necessary, although I would be interested in doing that in my own time, just out of my own interest. But anyway, so we've added the layers, we've added it into the generator, we've compiled it, and then we have our saved model, which we're going to see in the next file. We're going to be inputting into the actual camera capture. Okay, so here we have the motion recognition camera file, which is the file that actually picks up the camera capture and applies the model in order to identify the emotions. So it's pretty simple. We'll just fly through it. We have here the face cascade. This is the OpenCV inbuilt facial recognition model that's already been pre-trained for us. So we just use that there in order to identify the face and then pass it through into our model that we just trained earlier, or that you saw the output of earlier. So we have the weights, and then we have the emotion categories. So each one of these is in the order of the correct emotions based on the FAIR 2013 categories. Here we have the camera being captured. Run through it, basically just preparing the capture to be input into the model as a single image. So it loops through every second. The frame is treated as a single image. It's changed to black, put it to grayscale, put into the correct format. And then we have the facial detection, change it into pixels, taking the model.predict and passing through the image pixels into the prediction model. So we have then storing that into a NumPy array. That's basically it. It's the array is output onto the overlay screen, which is a copy of the input camera, and then we put it onto a little transparent or rectangle, as you've seen earlier, and then we save the top emotion into a .text file, which is then read by the Tetris application, which we'll look at now. Okay, and here we have the actual Tetris part of the application, which is I'm not going to spend as much time on this. I will just highlight some of the areas that I think are worth mentioning and worth highlighting. So here we have the arrays that show the shapes, and each shape is represented by a 0 in a nested array with dots indicating a blank space on the grid format. Look through, we have the class for tetramino, that's tetramino being the actual shape, as we mentioned. We can just look through here. We can see some examples of unit testing. These are left in the code, but they're just essentially not doing much. They're just taking in information, returning filler information, mock data, just to test different pieces of functionality before these functions were written. I was able to return and make sure that the previous function was working, given the correct input or an example of correct input. So they're still there, and you can see that the call for them is commented out in the code as well. So that's just left in there for the benefit of that, documenting that. So some other things to discuss. I think we can look down here at the current emotion function, which essentially just reads the file, strips the file and reads what is saved to the text by the emotion recognition camera, and then outputs, changes it to whatever the corresponding emotion is, which is then output on display by one of the emotion label. Actually, it's right here, which just shows the current emotion, and the emotion, the color is then changed also by if the whether the emotion is happy, neutral, or else, which would be negative, as that's all that's left. Okay, and one more thing to just mention is the difficulty section, which is, we can see here commented out, is the traditional or basic way that Tetris will increase its difficulty, which is that it will work over time. It will simply check how much time has passed, and then increase the time based on that, and reset it every so often. So it's just a regular increase in time up until the max difficulty is reached, which is when there's less than 0.1 seconds between each piece movement. But we can see the motion one here, which is what's currently in the application, is if the difficulty, if you don't want to increase it too much, but if it's happy, then it will decrease the amount of time between the pieces moving, which will make it more difficult. Likewise, if it's neutral, then nothing will happen, but otherwise, as in everything but happy or neutral, it will increase the time between the pieces or decrease the difficulty. A little bit confusing, that's the opposite way around, but that's how it is, and that will also be fed through based on the labeling system. So that's basically it. There's plenty of comments in there. I don't think there's anything else worth noting in terms of complexity. The game itself is actually quite straightforward, and so I guess that's it for me, and that is Tetris Flow. So hopefully you understood the application and the way that it works, and the functionality, what we were going for there. If you have any questions, please feel free to get in touch. Happy to discuss further, and thank you very much for listening.